इसका पासवर्ड क्या था वाईफाई का? क्या है पासवर्ड क्या इसका? कुछ कैपिटल है लोअर? ये तुम्हारा है? किसका है ये? चलेगा? फाइल मेल कर देते हैं, उसे क्लिक कर लें। बस कर रहे हैं। Okay. All right. So welcome back, everyone. Today's tutorial is about. So there are three tasks. First two are, all of three are kind of self-driven. We wanted to understand. So one of the things we look into, we understand that generally we don't keep a password or don't store our password as plain text. Yeah. So we said we store in hash forms. What is the use or significance of having hashes? What if someone get those hash code? Can they retrieve your password? No, because hash functions are one-way functions. If someone know your password, they can create the code. But if you have your code, you can't create your password. That's why we use hash functions. But there might be possibility where the way the way virus works, no, generally, and the way you detect is because they look for in your system, your IDS or whatever integrity tool you're using, it generally checks for hash code. It always matches, and then so something has changed because hash code doesn't match. But it might be the case attacker can change message and the password itself, both things. Yeah, every time when you check it, it saying okay, it matches because the whole password and the code also change. Both things are changed. So maybe having the hashing code may not work. And also this is a general understanding that if you have hash code, you cannot derive passwords. It really depends upon what is the input size, what is your password. So let's say if your password is one of the commonly used passwords, I can pre-compute all the hash code of commonly used passwords. Yeah, I can pre-compute those, and whenever I see a hash code, I can compare those hash codes one of those that I have. If it matches one of those, I can get to see this is the password. Yeah, so people can pre-compute those things. So if you have a really strong password, difficult password, I might not have that pre-computed hash code of it. So kind of very first exercise is about that. So there's a kind of online tool, online website that can help you to create hash code of a password. So you can put any password and you get the code. You go to another site, Crack Station. You got the code and submit to another site. See if that site can crack it. Do they know what is the plain text, what is the actual password? Yeah, so just go through this task 1, and then I gave you some other explanations. So it's a password hash cracker. So there's a website, crackstation.net. It uses massive pre-computed lookup tables to crack password hashes. These tables store a mapping between hash of a password and correct password for that hash. First, generate the hash of your password from the giving link. So if you go to this link, passwordgenerator.net, it will ask you which hash code you want to generate, which hash function you want to apply in a way. Do you want to apply SHA-256 or 1 or 2, whatever? Yeah, so that you can generate hash code for all three, just to build your understanding. And then you go to Crack Station. After generating hash of your password, pass the hash code that you have to this Crack Station site, and then see if it can crack it. Can it get a sense that what was the initial password that you have? So say you can start with the keywords that are very commonly used, and then you can later change them on a bit difficult side. So you start with the password that mostly people pick up, like 1, 2, 3, or hello, for example. So the first subtask, say try hello to get the hash code from this, and then pass whatever code you got to Crack Station. See if it can guess your message, your password. Secondly, you can make it a little bit tricky. Put some, for example, an ITM group or any other message, or add some string, number, special symbol, whatever, and try repeat that thing. Yeah. So that is the simple exercise that we need to do in task 1. There are 2 websites. One website give you the code. Other website will simply check if it can guess the password. And now you start with simple message, simple passwords, commonly used passwords for name, and then you go a little bit difficult. So you try like range of password and see which of these can be guessed. Are you able to open both sides? Are they working? Because sometimes one of them doesn't work due to firewall block or so. Both are working? So our aim is to identify commonly used passwords that these sites can crack and see how many passwords you can guess. Why this site is able to crack those passwords? Because site has already pre-computed those passwords. They are commonly used password, and we know some of the people always have those. So you can pass those names to the one of these functions, pre-compute them. Whenever you receive similar hash code, you compare with the one that you have. So you can play around string numbers, use simple like hello, password, whatever you think people might have. Number, year, for example, city name, pet name, flower name, sometimes those passwords. Sometimes people put password as a password. Yeah. So that was very common at some point. Maybe you can try your own password, see if it can whatever you have. If those are simple ones, it will crack it. Yeah, in a way. Huh? Okay, so those are complex passwords. That means you can try with simple ones. Let's say hello, or passwords, or flower name, city names.
इस लिस्ट जो है here, so पासवर्ड होता है सिंपल वाला, वो मुझे लगता है इसमें से डिटेक्ट करना होगा, इसकी बट लिस्ट में होगा वो पासवर्ड.
जो commonly named passwords हैं, so we say these hash functions work one way. These are one-way functions. You know the password, pass to function, get the code. Yeah, we believe if you have a code, possibly it's impossible to derive the other way. Having the code, you cannot derive the password. But what you can do is you can pre-compute some of the passwords. You decide some input, think of what generally people might put as a password, hello, or whatever, city name. And I can pre-compute all those hash codes, put into a table. Whenever I see a hash code, I try to match in my table, and I have that mapping. If this is the hash code, that means this is the password. So that's what it does. For simplistic password, it can identify. For difficult one, it won't be able to do it. It's all about how large you can pre-compute. If I have enough storage, I can pre-compute a lot more things. Yeah. All the combination that I see, alphanumeric here and there, whatever I can think of. Maybe there's a data breach. Like kind of guessing, yeah. It's just comparing the hash code from the pre-computed code. If your code is one of those codes, it has that mapping that this code is for this password. I think knowing the function is not important. Making a password difficult will make a sense. Because these hash functions are publicly known. Yeah, I can pre-compute with whatever generally people use, whatever standard says. So currently standard says SHA-256 is the standard. Anything below generally is not in practice. Yeah, so you see most of the system are using SHA-256.
So if I know hash code, like आपका hash code पता चल गया पासवर्ड का, MD5 फॉर्मेट उसमें यूज हुआ है, so मैं क्या करूँगा, मैं अपने लोकल पे रजिस्टर खोलूँगा एंड मैं वो हैश कोड वहाँ पे डालूँगा और उसमें जो एल्गो यूज हुआ है वो लिखूँगा, तो वो नॉर्मल वे में चेंज कर देता है पासवर्ड, ओरिजिनल क्या लिखा हुआ है वो पता चल जाता है.
Sorry, what? Can you repeat it? So you want to know the password from your database? Okay.
Hash code.
Hash code. Okay, so what do you do?
open my spread, then insert hash punch code
Okay.
in the field like PHP my admin के अंदर जाके
Hmm.
या hash code उसमें प्लेस किया
Hmm.
और फॉर्मेट प्लेस किया और जब फ्रंट एंड में आके देखा तो चेंज कर दिया उसको
So that is the thing, because your database have that mapping. So whenever you put hash code, it always match. So does this hash code matches one of the, in the database? Yes, then it has mapping. What is the password for this hash code? So if you know the hash code, you can't derive password. But the other way you can pre-compute, and then once you have that mapping, you can say that. And that's what is happening here. If you have a difficult password, probably there won't be any pre-computation.
combinations are in place if password is difficult.
Exactly. If it is one of the usual password, it will be cracked. It's very easy to crack, in fact. Right, so what are those commonly used password? You could figure it out. Sorry. Right. So this is very simple example, but you can think of if, as an attacker, if I have enough space, I might also pre-compute those combinations. Yeah. So simply having hashing may not secure enough. That's why we call it. What we do is we say we will be using salt in this. What is salt? I'll pick some number, some random number, and I'll pass that number as well along with my password, for example. Right? So it becomes impossible someone to have that mapping. So you're mixing some salt to it. Right, so it's a very simple example which says do not use commonly used passwords. If you do this, machines can crack in seconds. It's very simple to do this. Right. Now when we are done with this, let's move to, are we done with this? Okay, let's move to task 2, which is help you implement how you implement and compute hash in Python, how you use hash lib. Yeah? So it's a hash lib, it implements a common interface to many different secure hash and message digest algorithms, including SHA-1, 224, 256, 384, 512, as well as RSA's MD5. By the way, we don't use MD5. It's been considered insecure. SHA-1, we also stop using SHA-1. So we use 224 onwards, standard 256. Older algorithms were called message digest. The modern term is called secure hash, the same thing. So then we wanted to say, now try to run a little code. Maybe you can create a file and see what it does. Yeah, so it's a way how you create hash code, but also build understanding what are the different encoding format that we need to derive. And it gives you some understanding. For example, in this, we are using dot digest function and then dot hex digest function. So what is the difference in a way? So I give more kind of explanation here, but we can talk more. And then for Unicode, what is UTF-8 and 16 and 32? So give you kind of more detail, so you have better understanding. And then possibly how you update the hashes and how you play with the strings and bytes in this. So what you need to do, just follow the instructions, understand what we need to do, and then try repeat to see what happened in your system when you do so. will be the scenario where we need to use UTF, not byte. Yeah. So they are different. So I said here, if you are working with a string in Python, generally you represent them in bytes or with some Unicode format. Right. So for example, we have three UTF 8, 16, and 32. Why we need UTF? Why do we need it? Hmm? So generally, system can handle most of the files in bytes. It doesn't require it, but if you have data that doesn't support or in a different format, for example, it says, so Unicode is international standards, and there's large number of characters with 154 modern and scripts. International standard means for every language, they have some format to do. Yeah. So we are talking about very large number of characters that need to represent with some uniform encoding. That includes English language, Hindi, whatever. Yeah, different other languages. So if you are doing anything with other languages, you can use international standards. You have to represent outcome in UTF format. So the encoding and decoding becomes easier. For example, if I'm sending something from here in China, whatever, in Chinese, so it becomes much easier to represent those if rather than in other language. They might not convert or encode or decode properly. And then depending upon how many bytes it takes to represent every character, simply says, do we need to use UTF-8 or 16 or, yeah? So just go through this document and kind of click the links that I mentioned if you need more information to understand. Sorry. No. So digest size is what it represents? 260. 32 in what?
Entire string. This is representing the return type which is class string. Then this is 32 and block size is 64.
So 32 times 8. What is 32 times 8? 256. Yeah. So that means we are using SHA-256. SHA-2, yeah. So 256 bit should be the outcome, which is 32 bits. Block size is generally what is the size, because each of these algorithms also have their block size. So if you want to perform hash over a really large data, generally they have their own, internally they have their own blocks, number of blocks that it go through. So they have their complex internal structure, the way they look for. So generally, depending on the algorithm, they pick their own defined boundaries. So let's say they have large number of bits, internally they divide bits and then do some calculation, and then at the end you got this hash code. So internal, yeah. So every algorithms, yeah, they have their fixed block. They have internally their process, how they process the data. Yeah. So for example, SHA-256, this has 64. Okay, are we done with this? So let's move to the exercise 3. Now task 3 is about Ukraine power grid attack. So the other day we talked about the StuckNet. Let's talk about what happened there. I possibly also cover this in one of the lectures, but just give you some sense. Does anybody know what happened to this attack? What was the cause and exactly? So this is considered one of the most powerful attacks so far. Yeah, it happens in 2015, 10 years back, where what was happening, it's in one of the power company in Ukraine. So in generally those kind of systems, they have a routine job, right? Every 8 hours or so, people go, and then new people join in, and so on. So that was the time where operators at the control center, they were kind of heading at their homes, and new people are coming to join. Yeah. Suddenly, one of the operators start realizing that somebody has controlled their cursor. So he picked mouse and tried to control it. Nothing happened. And after he realized somebody logged him off, so he's found his computer log off. He tried to log in. It didn't work. It didn't work. He moved to other systems, other operators, try control. Nothing happened. And after a while, you realize there's no phone call, nothing. All is cut down. You can't report anything. And then you suddenly got to know something has happened. A substations, several component is destroyed. There's no electricity. It's all happened in a few minutes. Everything. And they start panicking. What happened actually? So, if you look at this case study, say 230,000 consumers were in dark for around 6 hours. So for 6 hours, there was no electricity. Fortunately, they had some backup, so it went up quickly. But in most of the cases, sometimes you don't have recovery takes months. Sometimes, yeah. So they actually targeted 30 substations and 2 distribution centers, and they destroyed large number of component. So there was investigation going into what happened, And then when they did this forensic investigation, they come to know that one of the operators clicked something in the email. So they opened one of the Excel document. Now in Excel, we have something called macro enabled. So in macro, we can program it. When you open it, when you click it, some code will execute it. So there's always an option you can enable or disable macro. So that person, without understanding that it's a spear phishing, he just click it. That malware get into the system, created backdoor entry for the attacker. Attacker get into the system, change the password. So he changed the password, so operators, you can't log in. Now, then he moved to something called domain controller. Domain controller is the place where all the passwords, VPN, credentials, all there. Person has access to all of those. Access all the devices remotely. Upgrade them. So change the firmware, change the software of those devices. So even if you are accessing from other devices, sending command, for example, they were opening circuit breakers. So they can create blackouts. Yeah? And then you are trying from other system, you are trying to close those breakers. Since the software has changed, those commands will not work. So they tried, but nothing happened. Yeah, so they have changed the firmware, run the command to open XYZ, destroy, whatever. And once they are done, what they did, there's something called kill disk. Kill disk is a software that can wipe out your memory. So there's no footprint. If you try to do forensic, what happened? Are there logs, anything that you can look into? There was nothing like that. Even it does not allow you to reboot. If you reboot, it doesn't work. So there's no footprint, there's no forensic that you can look into this. So that is about that. And after this, people will start realizing that this could be happen to any country. Yeah, because there's so many insecurity, there's so many issues with those. We don't really understand cybersecurity of it. And it just started with a very simple spear phishing email. Somebody click the document, get into the system, and all this happened. So this is all about that case study. So I've created a document and picked some document, some images and so on. Just go through this, try to understand in a more detail. And as I said, they also cut down communications. So you can't really report what's going on. And this all happened so quickly in few minutes, people did not understood what happened actually. And at present, we don't have solutions for many of these problems. So you can Google and understand what is kill disk malware, for example, what it does. Yeah. If I just say you see 23rd of December, which is really kind of cold winter, yeah, peak winters. Power grid in two westerns oblast of Ukraine was hacked, which resulted in power outage of roughly 230,000 consumers in Ukraine for 1 to 6 hours. Cyber attack was complex, consists of the following step. Prior compromise the corporate network using spear phishing email with black energy malware. So there was the Trojan horse was black energy. You can also Google it. And the siege SCADA under control, remotely switching substations off, disabling, destroying IT infrastructure component, for example, UPS, modems, RTUs, yeah. So control center don't receive any data, doesn't receive it. Destructions of files stored on servers, workstations with kill disk malware. Yeah. DOS attack on call centers to deny consumer up-to-date information. Because when there's a blackout, people are panicking. It's not just the company. People start phoning to the company. What happened? Because this was very unexpected. For Western world, if there's no electricity, this is a surprise for them. Yeah. For us, like there's a power cut. But for them, it's a big deal. We don't have power cut there. It's something, we only have power cuts when there's a maintenance going on. And most of the time, they drop you email or message saying, today or tomorrow, there will be work around at this time. So you have a sense. When there's a problem with sewer line or water, they give you notification kind of, we are working, there is some fault. It will be fixed by today at this time. So you have an idea that something's going on, that's why there's a problem. So for them, 6 hours is a very big deal. People were panicking, start calling. And customer center has no idea what's going on, why there's no power, right? So the emergency power utility company operation center was switched off. So they also switched off the emergency units. And practically in the sense, when attacker did this kind of thing, they do some mock test before they hit it. So they created black energy. If you see, the black energy was invented 2007. So they tried kind of at smaller level what it can do. How can you get into the system? So they make certain trials. And once they get a sense that this is the process, it will work. And that becomes a part of it. So in 2015, they hit it after several years of trial. And they know that people will look at the forensic digital print, what happened to this. So this also executed kill disk. When you do this, it's wipe out all the memory, destroy your memory. There's no footprint, you can't read. So it's kind of sense a cyber threat landscape in Ukraine. So in different sectors, attackers. So Ukraine is considered one of the insecure in terms of cybersecurity. And if you look at this red one, 10th attempt, work for them. So they tried several attempts on different sectors, but then this was the one they were able to make it. So just go through these activities, these steps, what happened, and there's certain figures there that will also help you build understanding what attacker did in stepwise. Now, one of the key problems of solving these kind of problems is when something like this happens, what are you going to do? If you are a owner of this company, yeah, what you will do when you heard somebody has compromised XYZ? Who will you report? Who will solve this?
Who's taking care about IT infrastructure?
I mean, internally you can look into what happened, but why did it happen? Why did it happen? Who are the people responsible for this? How do you can look into what are the issues, how can you fix this, but then you also want to penalize the people who did this, isn't it?
There's a chain in between the external and internal approach. A link in between the external and internal framework.
Yeah, but sometimes you don't know who are the attacker, what their intentions, because sometimes, practically we think what kind of people might have this kind of interest. Most of the time people are more interested in stealing bitcoins, for example, yeah, individuals or group of people. But if somebody doing this kind of massive attack, it's not individual interest, definitely. Yeah. So, and most of the time it could be state terror, maybe Russians did this. If you don't listen to me, I'll do, this is one of the example, but I can do hundreds of these kind of things. Yeah, directly on that. They won't say, but this is a cyber war. But then with this example, US, UK, all the big countries start, especially in the US, they have a very large grid. Yeah, there are a lot more things with electricity they are relying on. So if they don't have electricity, it's a very big problem. So they start thinking how we can make it more protective and so on and so forth. Because we don't have expertise. We have IT security people, but they don't understand OT systems. They don't know what devices are, what protocol these are, They don't know all those things. And therefore, in the last 10 years, a lot of work people have been doing in this cyber physical systems to try and understand those things. You like or not, we have to fix them as a utility. Yeah. And again, as I said, it just started with a phishing email. And they target the person who doesn't understand what is spear phishing. Those are the people who are electrical engineers, operators, and they just clicked on it. And spear phishing is now more customized. It's very customized. Someone seems to be your boss. Oh, send me this file immediately. I need it 5 minutes. And you forgot to actually check what is the email address, but the name is same. And then most of the people simply send it. And again, it's not easy to detect and understand it's a spear phishing or spam or whatever. And like every other system nowadays connected to internet, right? So they always look for who is the weakest link. easily target that person, give them some incentive. You know, if you buy one, to get to whatever 50% off, and just click it. Yeah, people do that. Um, even the people who are expert, sometimes they don't really get. So in order to attack those systems, you don't really need engineering. You just need to understand how to target, how to get into the system. There are several doors. Which is the weakest door? Which is easier for you to get into? That's it. They also destroyed RTU. So if you are destroying RTU, sitting at control center, there's no data coming to you. Yeah. If there's no data, you can't process anything. You have no idea what does my system look like, whether stable, unstable, destroyed. What part of the system still can work? It's, still functional. What part of work is part of the system is gone. So takeaways. It says know your environment. We talked about this before as well. Identifying key OT processes and data that needs to be protected. Understand the threats. Segment your OT and IT environment. So that, because most of the time what happens, attacker target IT system. Somebody targeting operators with a spear phishing, it's an IT network. But then attack propagates from IT to OT. Yeah, because most of the OT network is disconnected. It's not connected to internet. Anyway. Focus on cybersecurity basics, strong passwords. Maintain your OT security posture. Think about the patching whenever you can. Focus on proactive monitoring and detection, not just compliance and reactive. Don't just think about that there are regulations, you have to tick the box. Think about proactively. Do risk assessment, understand what could be the potential threat, plan what solutions you have, what you need, and then think accordingly. Train your operators, more importantly. So now you see that a lot of cybersecurity training are giving to the people, electrical engineers, and who work on power systems. Develop an OT incident response plan. When something goes wrong, how are you going to handle it? And always you have to have red team and blue team, right? Defensive, offensive team. So whoever working in your enterprise as your cybersecurity people, you kind of build two teams. One team will think about defending it. One team will think about how to attack your system. Think like an attacker. What would you propose to stop such attack in the future? So if I ask you what are the 3 things you will do, there might be several things that we can do, but what are the 3 key things you think were the main kind of points of this attack? How would you stop this attack? Let's say if I say, okay, go back. This is something happened, but you have opportunity to go back and apply any 3 things. What would be those things that can stop it or mitigate it in some way? Yeah.
Sending the information in or out. Second, educate the person or the those who are working.
But how would you filter? What filter you?
Filters in the sense of we have spam filters, other filters nowadays, so we can increase and making typing or just mentioning patching work. So it is also kind of patching. It means we are improving our filters, improving our distinguished layer that we can add in between the in and out, infra and intra.
Yeah, but even if you have a filter, it's just an email with an Excel attached to it. Yeah, so if somebody is sending you Excel file or Word file, your IDS won't pick up it. It will say it's all good, no issues, unless you click on it. If you don't click it, there's nothing happen. If you click it, yeah. So sometimes the solution, the tools we have might not be effective. They may work, they may not work. And an attacker are smarter to, their intention is to how to bypass what you have. That is their first step. In order to perform an attack, they will get to know you have this IDS, you have this filter, whatever. They will design this, they'll pick that method that can bypass those things easily. That's why cybersecurity is kind of complex. Despite of having solutions, we think that this will work, but it doesn't work when someone hits it. Because attackers are smarter than the people who are thinking, defending it. Because they're not thinking like an attacker. They're just thinking, do encryption, blah, 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 and everything will be sorted out, which is not the case. Because attacks are also customized. The way they've been targeting system have been changed. They are more in APT in nature. They get into your system, bypass your detection system, and then start working. So you don't detect it. So what are those three things? Think about it. Let's think about 5 more minutes. Okay, so let's assume those filters. What else?
Stays on the basics of cybersecurity, like for example, check the URL from where we are getting the information.
Yeah, no, I'm just talking about at higher level. So this could be one of the examples of spear phishing, but there are several other ways. So when attacker will target next time, attacker knows that you know what is spear phishing by that time, so he will not repeat the same process. Yeah, they will pick some other method, get into your system. They will knock the different door, not the same door. Because you might have some solution that.
Again, you're seeing words, we have two different teams like blue and red. So think about like the right teams and try to find out the vulnerabilities of the entire systems and try to fix it on in a regular basis, on a regular basis.
Right. So I guess it's all about building and improving your own team. You do a lot of penetration testing. Think like an attacker. Test it, what will go wrong. That's why risk assessment and these processes are really effective to understand what can happen to the system. Do we have that capability? We have people with trained skill. Do we have tools that we can apply, and so on. And yeah, if we have two teams, always go and see what you can attack, what you can defend. Something like this happens, how will you react, right? So in this case, even they did not realize what happened, but imagine even if you know that something wrong goes, it is happening, how quickly you can react and how effective your response would be is the key. If we don't really understand what's going on, we can't really put what to do at this point. That's where understanding indicators, profiling attacks, and so all those make sense. But then this kind of field also requires a lot of research. Come up with those methods, solid methods that have proven their effectiveness. One of the problems with cybersecurity methods is many of these methods are there, but there's no research around their effectiveness. Right? So let's say we say RSA is secure, for example. Use this is secure. But we are not talking about this security with respect to the hardware, with the computation that we are saying. Everything is relative in cybersecurity, right? As I said, you can put a plastic lock, maybe 5-year kid won't be able to open it. So it's all relative. He won't be able to do this, so anything will work. So in a similar way, you need to know what is the capability of attacker, how smart they are, and you have to think ahead of them to secure it. Otherwise, there's no way you could do it. Right, so let's stop here, and we'll come tomorrow with new topic.
So that is my question again. Say, how could you investigate such attacks if targeted enemies? हमको कैसे इसको उस मॉड्यूल को अपडेट करा था 2015 क्योंकि हमारे पास तो उसके कोई स्टेप्स नहीं कर सकते, कोई ट्रेस बैक नहीं थी हमारे पास. How the investigation find out कि they run this till this company?
So they wipe out some of the systems, not all the systems.
But they still get some traces.
There are some traces. Yeah. Immediately you won't be able to do, because attacker's intention was to run it, to wipe out, so that they cannot get it. But when you do this,